Alright, welcome back everybody. In this video we're going to look at, again, how we convert back and forth with various types of linear relationships. This video is going to focus on converting back and forth between graphs and equations. We're going to start by going from an equation to a graph. So to convert from an equation to a graph, it's usually the easiest thing for us to do to get the equation into slope-intercept form, which you should know slope-intercept form is y equals mx plus b. And then use the y-intercept and the slope to create the graph. When we have them in slope-intercept form, this number in front of the x coefficient, represents the slope of the graph, and whatever number is being added on the end represents the y-intercept. So in part A, we have an equation here already in slope-intercept form, and so we can identify from this that the slope is 2/3, and the y-intercept is -4. So we always plot the y-intercept first. It's where the graph crosses the y-axis, so we'll go down to -4 on the y-axis and plot a point. And now from that point, we want to use the slope to generate additional points. Now remember, the slope represents rise over run, and when it's positive, the graph should be rising as we move from left to right. So slope of 2/3 means I'm going to go up 2 and over 3 to the right, and up 2 and over 3 to the right. And then I'm going to break out my handy dandy ruler, and I'm going to draw the line through those points. And there's the graph of y equals 2/3 x minus 4. Now in part B, the equation that we have is not in slope-intercept form, so it's going to be best for us to convert it into slope-intercept form before we convert it to its graph. So in order to do that, it's a relatively simple two-step process. We are first going to distribute the -2 through the parentheses on the right-hand side. So -2 times x gives us -2x. And -2 times a -1 gives us a +2. And then we will add 3 to both sides to get y by itself. And we end up with the equation y equals -2x plus 5. Now we identify the slope and the intercept. The slope is -2. The y-intercept is 5. And so we'll start by plotting the y-intercept. So we go up to +5 on our y-axis and plot a point. And then the slope is -2, which realize, again, that -2 means -2 over 1. When a graph has a negative slope, that means that it should fall as we move from left to right. So I've got a rise of -2, and I go over 1 to the right. Down 2 over 1. Down 2 over 1, plot a couple of those points, and then I break out my handy dandy ruler and go ahead and connect and draw the line through those points. And there's the graph of y minus 3 equals -2 times the quantity x minus 1. Okay? So we get it into slope-intercept form. Once we do that, the graphing part comes relatively simply for us. Now let's go to the flip direction. In this case, we're going to write an equation from the graph. And when we try to do that, the easiest thing for us to do is just identify the y-intercept and the slope on the graph, and then put those into the slope-intercept form to write the equation. So first, I'm going to look at the graph in part A. I identify the y-intercept. Gotta stop doing that. I keep forgetting to turn my pen on and I keep grabbing stuff instead of writing. We identify the y-intercept, which is where the graph crosses the y-axis, and that happens at 6. +6. And then we identify the slope, and the way we're going to identify the slope is we're going to find another point where the line goes exactly through the grid, and we're going to identify the slope by using rise over run and reducing it if necessary. I see that the line goes through this point right here. And so to get from one point to the other, I go down 2, and I go over 4 to the right. So the slope is going to be a rise of -2 with a run of 4, and I can actually reduce this to get a slope of -1/2, which is exactly what I would have gotten if I had picked this point instead. And you see that the line goes straight through the coordinate grid at that point as well. Now that I've identified the slope and the y-intercept, it's simply a matter of using y equals mx plus b form. My m value, my slope, is -1/2, so it's going to be y equals -1/2 x, and my y-intercept is +6, and there's our equation. And that's how we can convert from a graph to an equation. We'll do the same thing in part B. First, I identify the y-intercept, which is where the graph crosses the y-axis. That happens at -5. And then I want to identify the slope. And so I'm looking for another point on the grid where the line goes through there. It goes through this point right here. And so my slope is going to be rise over run. To get from one point to the next, I go up 3 and over 1. So my slope is going to be 3 over 1, which I can just write as 3. And now I'll write my equation. Y equals mx plus b. Now plus a -5, so I'm just going to write -5. And there's the equation that represents that graph. So that's how we convert back and forth between graphs and equations, either from an equation to its graph or from the graph to its equation. All right, that's it for this video. See you guys next time. Have a great rest of your day.